Okay, we decided horizontal shift right was in blue. Okay, we can look back at our cheat sheets. It says if you want to go right, you subtract from x on the inside. Okay, so subtract 3 from x, which really means inside. Right, and then reflection over the x-axis. You've looked at that one. We can look again if you think you need to see it one more time. Reflection over x means basically multiply the whole function by -1. Looks like this, right? -1 times the function. So we're going to multiply the function, the whole thing, by -1. Okay, let's apply our transformations. G of x, it starts out as the original, 2 to the x power. Now our first move is to subtract 3 from the x. Well, if x is up here in the power, that means when I subtract 3, I've got to subtract it from that power. Okay, and then the second change is to multiply the function by -1. So all that's going to be is -1 times that stuff right there. So your final function, right now as it is, it looks like this. -1 times 2 to the x minus 3 power. That can be written as -2 to the x minus 3 power. Notice that that -1 didn't affect inside the x. That's not part of the outside. That would be the inside. Okay, next one. Never did any lefts. I should change this to left because we did all kinds of horizontal shift rights in here. I get to say that. I get to change it whenever I want. If I decide I want to change it, I'm going to change it. Okay, this one is the log function. Now, we haven't talked a lot about logs yet. We will in the next section, but as far as this parent function is concerned, just the log, that's just like an operation. It's just like a cube root or multiplication or something. The 2 is called a base. It's not important. What's important is this variable right here and the whole function, including the log. Just think of those as like a cube root or a square root. Okay, here's our transformations. First one says to do a reflection over the x-axis. We know what that means already. We've looked it up a few times. That means multiply the whole function by -1. Basically changing the signs. Okay, the next one says vertical shift up 3. We should have done it down. We didn't do any downs. Sorry, you guys get the idea. So I'm going to add 3 outside. That means on the end of the function, I'm going to put a +3. Okay, this one says a horizontal shrink by 1/2. Now, horizontal shrink, horizontal, automatically, your brain should be going off bells and whistles. Something's different about horizontal. Oh, it's always backwards. Okay, let's go back to our reference sheet and make sure we remember horizontal shrink means we have to multiply, but we multiply by the reciprocal. So it says horizontal shrink by 1/2. That actually means I'm going to multiply inside. That means to the x by 2 because that is the reciprocal of 1/2, right? Reciprocal. All right, let's apply these. We'll do one at a time. Slowly make our way to the finished one. Okay, g of x, our new one, starts with log base 2 is how that's read, of x. and we need to multiply the whole function by -1, which basically just puts a negative out in front of that word log. That's it. I mean, you can write it as -1 parentheses, but it doesn't really do much besides that. Okay. Next one says to add 3 to the outside, so I'm going to go plus 3. Now, just as a side note, there is something different between the plus 3 out there and if I had written it as parentheses x plus 3. The difference is this plus 3 was shifting up or down because it happened outside. This would be shifting it left because I put parentheses in there. Something to keep in mind when you're doing these insides and outsides. Okay, last one says we're going to multiply inside to the x, a 2. So inside here, I've got to multiply by a 2. So here I am at g of x equals, our negative is out in front. I'm not going to have enough room. Wasting time, lady. G of x equals negative, then you'll have log with the little 2, x, we have that negative out in front, and we have that plus 3. Now, if you wanted to make it clear that that 2x was together inside the function, you can put a set of parentheses. Just do not include that plus 3 in the set of parentheses because that's outside the function. X is the inside. Either one is fine though. Or you can write it like this, and then that plus 3 is out to the side. Okay, one more. Original function is a cubed root. We've got a couple changes to make here. First, it says to do a horizontal shift left 4. Back to our cheat sheets. This time we're shifting left, so we add inside to the x. So it's going to be this kind of change. All right, this means to add 4 inside to the x. And then we've got a vertical stretch by 3. Vertical stretch by 3. We know these already, right? Vertical stretches mean we multiply outside. So this we're going to multiply by 3 outside. And then this last one right here is a reflection over the y-axis. Now that's a first, so we better go back and double check. Reflection across the y-axis this time says multiply the x inside by a -1. And then if there happens to already be something inside there by the x, you apply the negative to that as well. All right, so we're going to multiply inside by -1. All right, one at a time. G of x, our new function, equals the cubed root of x. But the first change says to add 4 inside on the x. So plus 4. Okay, next one says to multiply by 3 outside. So multiply here by 3. And then the last one is to multiply inside by -1. Now, I don't want to confuse you with this whole multiply inside and this stuff. This right here basically gets replaced with a -x. So that negative applies to that x right there only. I think I confused you with my shortcuts there. Everything else is going to stay the same. This 4 isn't actually going to be affected by it because it was put there before I did a reflection. And we've still got this cubed root. Still got the 3 out in front. So our final function is g of x equals 3 cubed root negative x plus 4. That's it.